So we've been looking at vectors, and I wanted to make another video on doing a couple more problems, application problems involving vectors. And so in front of us is our first problem, and it deals with ground speed in the direction of an airplane. So it tells us that an airplane has an airspeed of 500 kilometers per hour, a bearing of north 45 degrees east. The wind velocity is 60 kilometers per hour, and the direction north 30 degrees west. Find the resultant vector representing the path of the plane relative to the ground. What is the ground speed of the plane, and what is the direction? So first thing that we want to do is we want to graph what we have. So looking at this, we have an airspeed of 500 kilometers, and that 500 kilometers per hour is at a bearing of north 45 degrees east. So let's graph that first. So we know that we're going from the north and we're going towards the east. And we're going 45 degrees. The length of this vector, the magnitude, is the speed of the airplane. And in this case, our speed of the airplane is 500 kilometers per hour. I'm just going to make it kph per hour. And then we have the wind. So the wind is a velocity of 60 kilometers per hour in the direction of north 30 degrees. So I'm going to start at the north, and I'm going to go 30 degrees towards my west. And it's 60 kilometers per hour. So I know that my magnitude is 60 kilometers per hour. So the resultant vector is the sum of these two vectors. So we have here, remember, we can write our vector, we can move it around as long as it's going in the same direction and has the same magnitude. So we have this wind here forcing our airplane. You can think about it going this direction. Same magnitude. And so it's forcing our airplane a little bit off course. And that resultant vector we can get by looking at, let's make a parallelogram. Maybe let me go over here. So we got this, we got this. This is 500. This is 60. And we can make our parallelogram. So one way to get that resultant vector is starting here, ending there. So our plane is being pushed by the wind, and this is our resultant vector. So a couple things that I see. I see that I know without my resultant vector in there, I know what this angle is. So let me just take this away for a second. This angle in here, I have my 45 degrees plus my 30 degrees. So I know this angle in here is 75 degrees. So that means the angle across here is also 75 degrees. So that's going to help me find the other two angles. So I know the other two angles, so let's call it theta. It's congruent to this angle over here, theta. I know the sum of all four of my angles is 360 degrees for a parallelogram. So I have 360 degrees is equal to 75 degrees plus 75 degrees plus 2 times theta, or theta plus theta, which is 2 theta. So 360 degrees is equal to 150 degrees plus 2 theta. Subtract 150 degrees, so we would get 210 degrees equals 2 theta. Divide both sides by 2, I get my theta is equal to 105 degrees. So I know what my angle is. Let's draw my picture again over here. 150 degrees. Put my resultant back in. So I know over here that this is 105 degrees. Or I can use over here, which is 105 degrees. So I know a couple lengths, and I know an angle between those two lengths. So if I know an angle between two known lengths, we have our triangle. I know I would be using the law of cosine because we don't know that this is a right triangle. And so law of cosines, let's call this resultant vector. How about let's call it V. Basically, we're trying to find the magnitude of V. And so we know that by the law of cosines, that magnitude V, quantity squared, this is equal to one of the sides that it's sandwiching the angle we know, squared. So 500 squared plus 60 squared minus 2 times one side 500 times the other side known, that's sandwiching it, which is 60 cosine of 105 degrees. So we're going to need to simplify this a little bit. So I have the magnitude squared is equal to 500 squared. Well, 5 times 5 is 25. Add on the 4 zeros. So I have 250,000 plus 60 times 60. So that's 3600, 3,600 minus 2 times 500 is 1,000. 1,000 times 6, that's 60,000. 60 is 60,000. Cosine of 105 degrees. So let's plug this in. So we have 25,000, not 25,000, 250,000 plus 3,600 minus 60,000. Cosine, make sure your calculator is in degrees. Cosine of 105 degrees. So I want the square root of that result to get what V is. The magnitude of V, our vector. And so the square root of my result is 500, approximately 519. So my sides are in terms of kilometers per hour. And so my resultant vector is 500, and the magnitude is 519 kilometers per hour. So this is actually the ground speed. So it also wants to know, it's going to want us to find the resultant vector, which I need to put in terms of I and j. So we're trying to find v is equal to the horizontal component a times my unit vector I plus b times my unit vector j. And I also need to know what my angle is to that resultant vector. Okay, so how are we going to do that? Let's think about this for a second. Well, we know this vector here that has a magnitude of 500. Well, it was northeast 45 degrees. So I know from standard position, this is 45 degrees. Or from here, it's 45 degrees. So I want to find this angle inside my triangle. Maybe let's call that alpha. So I know a side across from my angle. And I know now a couple things. I know an angle and an angle, a side across from it. So just found that this vector v was equal to approximately 519 kilometers per hour. So I know I can use the law of sines. So since I want to find an angle, let's put the sine of alpha in the numerator all over the side across from that angle known or trying to find, which is 60. This is equal to sine of 105 degrees all over the side across from 105 degrees we just found was 519. If we multiply both sides by 60, we can get sine alpha is equal to 60 all times sine of 105 degrees all over 519. And so if I took the sine inverse of that result, I get sine inverse of 60 times sine of 105 degrees. So plugging this in the calculator, make sure you put parentheses around that 105 and then divide it by 519. So we're talking about degrees, so I'm going to keep my calculator in degree mode. So sine inverse of 60, sine of 105, I'm going to close my parentheses off for the angle divided by 519. So I get that my alpha is approximately 6.4 degrees. So I want to know what the course is with that airplane with the wind affecting the airplane. And so I have my 45 degrees. So I know north to east, 45 minus my alpha. We call this beta. So beta is equal to my 45 degrees minus my 6.4 degrees. So looking at that, 45 minus 6.4, I get approximately my angle or my direction to get to my resultant vector. Actually, beta is going to not be exactly what I put. Beta is from here to here. So 45 minus 6.4 gives me 38.6. So the path of the plane relative to the ground. That is going to be, we're starting at the north. We're going 38.6 degrees, headed towards the east direction. So this is the relative course of the airplane on the ground because of the wind. So now I need to figure out what is this vector here. If I wanted to put this in terms of I and j, I need to figure out what this vector is. We know what the magnitude is, and so I need to figure out what is my horizontal component and what is my vertical component. So this is actually a right triangle. So looking at this, let's make our right triangle. We know what the magnitude is, which is the hypotenuse of our right triangle. It's 45 degrees plus that 6.4. So this angle inside is 51.4 degrees. So if I want to find my horizontal component of my vector, that's the adjacent side. Adjacent and hypotenuse, I know I'm using cosine. And so I know that cosine of 51.4 degrees is equal to the opposite A all over hypotenuse 519. So the horizontal component of my vector A is equal to 519 times cosine of this 51.4 degrees. So plugging that in, 519 times cosine of 51.4. This gives me approximately 324, or in terms of kilometers per hour. And to figure out what B is, I know B is opposite of the angle known. I have my hypotenuse, so opposite hypotenuse is sine. Sine of 51.4 degrees is equal to the opposite B over hypotenuse, which is 519. So B is equal to 519 times sine of 51.4 degrees. So B is approximately 519 times sine 51.4. So B is approximately 406. So I know what B is component, that's the vertical component of my vector. I know what A is, this is the horizontal component of my vector. So I know what my vector V is. This is equal to A, which we said was approximately 324 times I plus 406 times J, that vector. So that is my resultant vector of the true course of the airplane. So let me pull up another example for us to do. So the next example in front of us says, how much force is needed to move a 250-pound object up a ramp with an angle of elevation of 30 degrees from the ground? So again, we want to draw our picture here. So we have some ground. I'm going to assume that it's horizontal. We're not going to take in consideration friction. The ramp is 30 degrees elevation, angle of elevation. We have this is 30 degrees in here. We have an object, so let's say it's in a box here. And the weight, so that weight is pulling down. And that weight coming downwards is 250 pounds. So that magnitude of that line is 250 pounds. This angle in here is always going to be right. And it's not to scale. This angle, actually, 250 pounds. That's right. The 250. Actually is coming down like this. So what I was told, and what I'm going to tell you, is this angle in here is always going to equal this angle in here. I was kind of told if you like rotate this, we made a triangle. This is going to have that same angle in here. Probably the same direction. And this right here is always going to be right. This right here is always going to be right. That's 250. And we want to find the force. And so the force, we're pushing it up to keep it up on that ramp. We're pushing up right here. That force is going to be right here. So how many pounds right here? So let's maybe call this some variable, or this is the vector we're looking for. So let's maybe call it magnitude of V, that length. And this is 10 degrees, not 10 degrees, 30 degrees. Okay, because on these examples with ramps, and it's a right triangle, I have the angle 30. I want to find the opposite, and I know the hypotenuse, which is 250. So opposite and hypotenuse to me tells me I'm going to use the sine. And so sine of 30 degrees is equal to the side opposite, which is my magnitude of what I called vector V, all over the hypotenuse, which is 250. So sine of 30 degrees is 1/2 is equal to my vector V, the magnitude, all over 250. So the magnitude of my vector V here is equal to 1/2 times 250, which is 125. And since I'm talking about force as being pounds, this is 125 pound force is being applied to the object. So let me put on a different one. Second.